Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Gas Giants 33 times the size of Earth in Earth's orbit and zero proton mass. Now, in Article 620 entitled Huge Gas Giant Planets in the Inner Solar System, I showed that there is a very clear, neat relationship between the known gas giants' orbital radius and their radius. Gas giants, as I have shown in Article 523 entitled Planet X in the Solar System, Jupiter and all gas giants or recent acquisitions, are re-energized Planet X system stellar cores, which have gone to the Sun to absorb material. These objects are the dead and now solid core of a once living star. The objects gain a thin layer of gas from the Sun, and thus their radii remains essentially the same, which is why there is such a clear mathematical relationship between their orbital radius and physical radius. This can also be seen from the fact that the blemishes caused by the impact of comet Schumacher-Levy 9 on Jupiter on its atmosphere remain visible for months. And here you can see one of these stellar cores, which is in the process of turning into a gas giant. It already has stripes, but it's not a gas giant yet. It's still going through its process. It's still trailing materials, absorbing material from the Sun's corona. You can see that. But this is the process that these objects go through, that Jupiter went through a long time ago, possibly thousands of years ago, and then turned into a gas giant. And here are the blemishes which which remain visible for months in Jupiter's atmosphere. That could only have been created if there was a solid surface right below this gaseous atmosphere. And this is another one in the process of forming. So, in addition, the living planets in the solar system, such as Mercury, Venus, Earth, Mars, and Pluto, are very different from the gas giants, as they are much smaller and yet closer to the Sun. Gravitational energy must increase as we move closer to the Sun, as the Sun is the largest source of gravity in the solar system. And larger objects are supposed to have a higher gravitational energy, as is clearly demonstrated by the known gas giants. The reason why the rocky planets do not obey this relationship is because the rocky planets have living cores of different size, which cannot be determined from the outer radius of the object. If the gas giants were mainly made of gas, as is believed, then they would not obey this relationship like the rest of the planets, as they would all have cores and atmospheres of different sizes, which again shows that they have to be mainly solid, with a thin layer of gas surrounding the core. And here you can see the orbital radius for the four known gas giants and their physical radius. And you can see the physical radius decreases as orbital distance increases. So they exhibit this relationship where the smaller objects are further out from the Sun and the larger objects are closer to the Sun. The larger objects are supposed to have a higher gravitational potential. And you can see here how gravitational potential changes. It increases as we move towards the Sun. So an object closer to the Sun would have a higher gravitational potential and should therefore also be larger. But that doesn't work when we look at these planets, these rocky planets. Jupiter is much larger than all of them, and that shows you that Jupiter has a dead core. It doesn't have a living core like these planets. And these planets have cores of different sizes. Their cores are not exactly the same, in the same ratio to the rest of the body of the planet. And that's why they do not follow this clear relationship that we see with the gas giants. So the relationship between the orbital radius and the radius of a gas giant is given by this equation. And that tells you that the orbital radius is proportional to 1 over the radius, the physical radius of the object, to the power of 3 over 2. Then gravitational potential, because it's given by V, which is equal to gm over r, and this is gravitational constant, that's the mass of the Sun. But the 1 over r from this equation, if we write this equation 1 over r here, then on this side we're going to get r to the power 3 over 2. So that means that we can replace this r with r to the power 3 over 2, but we don't know what other constants we have, so we have to use the proportionality sign there. So that means potential is proportional to the radius of a gas giant to the power 3 over 2. Now, to see how much more energy is in a living core than in the dead cores of gas giants, we will find how large a gas giant orbiting at the same orbital distance as the Earth would be. And Earth's orbital radius is 1 AU. So from this equation here, we have that this object, I just wrote it in the opposite way. So I placed r as the subject of the equation, and then we would have the little r, which is the orbital radius, would then be to the power 2 over 3. And so that means that the physical radius of a gas giant at Earth's orbit, and 1 stands for 1 AU there, so it's GG1, is 1 over r e, which is the Earth's radius, to the power 2 over 3. And this is for Jupiter, so we have the same equation but written down for Jupiter, so J stands for Jupiter. And then what we do is we take one equation divided by the other, and when we do that we get this. So RGG1 over RJ is equal to RJ, Jupiter's orbital radius, divided by RE to the power 2 over 3. And then we're going to solve for RGG1. So this part we write as RJ over RE, all to the power 2 over 3 times RJ. And then we can plug in the numbers. So RJ, that's Jupiter's orbital radius, which is 5.2 AU. Earth's orbital radius is 1. So basically we have 5.2 to the power 2 over 3 times RJ. And we just leave RJ there. It's 3 times. This gives us 3. So that means that it would have a radius that's 3 times Jupiter's radius. And Jupiter is 11 times larger than the Earth. So that means we'd multiply by 11, get 33, and then we'd have the radius of the Earth. So this is how large this gas giant would have to be if it was in Earth's orbit, 33 times larger than the Earth. Now, Earth's core is 20% of the size of the Earth, so that means R for Earth core is 0.2 times the radius of the Earth. We can plug that into the equation, 33 RE, and RE now is REC over 0.2. And 0.2 is 2 over 10, which is in the numerator is 10 over 2, so that's times 5. 33 times 5 is 165. So that means that this gas giant that would occupy the Earth's orbit would have a core which would be 165 times larger than Earth's core. And this gas giant would have the same gravitational potential as the Earth, as it would occupy Earth's orbit. Then from equation 2, and there's equation 2, where V is proportional to capital R to the power 3 over 2, we can again write 2 equations. One is for the gas giants we had before, the one at Earth's orbit. And this one would then have a potential which is equal to the potential for Earth's orbit, so that's VE, and that would be proportional to its radius to the power 3 over 2, and its radius is 165 times the radius of the Earth's core. Then the one that would have the same radius as the Earth, and this one would be far out into the solar system, very far from the sun, but its potential would then be proportional to its radius, so we could write that equation for it. And then we're going to take one of these and divide it by the other. So VE over VGGEC, that's gas giant with the same radius as Earth's core. And then we have on that side of the equation this. So the REC to the power 3 over 2 will cancel. We end up with just 165 to the power 3 over 2, which is 2,119. And that means that living cores have about 2,000 times more gravitational potential or gravitational energy per unit mass than the dead cores of gas giants. even after going through the re-energizing process. Before the re-energizing process, they would have had no gravitational energy, since these objects will absorb energy until they have reached the density state they ended up with after going through the sudden destructive process, as described in previous articles, namely Article 618, entitled Planet X System Electrons Make the Energy of the Sun's Core Inaccessible. This means that their density state energy level decreased by a factor of about 2000. Since this number is close to the ratio of the mass of the proton to that of the electron, this suggests that they are only able to absorb gravitational energy from electrons, and their new mass comes only from these electrons. In other words, they have essentially lost their proton mass, and that's for the core, that they, of course, will absorb the sun's corona, and that will have some proton mass, but it's a very small amount. Basically, their mass is coming from the core, because mostly the object is the core. So that means that that core was not able to regain any mass other than from the electrons that it absorbed. So in other words, they have essentially lost their proton mass, and all the mass that they have gained comes from the electrons, which they absorb from the sun. So in conclusion, the sudden death process through which Planet X system stars and planets went through, resulting in the formation of stellar cores, decreased their gravitational energy absorption capacity by about a factor of 2000, which is the factor by which the mass of a proton is higher than that of the electron, which suggests that all the mass of the core's gain comes from the electrons, which they absorb from the sun or other solar system objects, and that their proton mass has been lost. The protons still exist inside them, and these protons have a positive electric charge, but they have no mass. This means that mass and gravitational energy is actually the same thing, and that particles only have mass when they have gravitational energy. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.